In this section, we will be discussing hierarchical clustering. We will define hierarchical, agglomerative, and divisive clustering. Then we're going to take the most popular one, which is agglomerative clustering algorithm, and list the steps for that process. And then for between clusters, we will calculate and compare single, complete, centroid average, and ward linkage methods. And then finally, we will use a dendrogram to select the number of clusters and identify instances in a cluster. So let's begin with hierarchical clustering. Why is it important? Well, back in the 1950s and 1960s, scientists in many different fields of science, biology, genetics, and ecology, for instance, they needed a method to classify organisms based on observable traits, genetic similarities, but they didn't have such a great method, so they wanted, rather than just putting it into fixed categories, they wanted some way to group species in a way that reflected evolutionary history, thus forming the tree of life. So something like the tree structure you see on the right. And that led to the idea of hierarchical clustering, where you group observations and hierarchies or levels. And this is done by looking at the data points and using pairwise proximity to group the data, where organisms or any observations are thus grouped by similarities. So basically, hierarchical clustering was originally invented to solve classification problems in biology and taxonomy, especially to understand natural relationships between living organisms. So here's a fun little example. Let's imagine that you're a taxonomist studying 30 animals, and you observe characteristics like number of legs, presence of fur, wings, etc. And you want to see which animals are closely related. Well, you can use hierarchical clustering to show how groups are split and merge by building this dendrogram that mirrors how species might have evolved from common ancestors.